Hello friends, today we are doing index notation. Our main focus will be to answer ECZ examination questions for paper 1 without any difficulty. Welcome to my YouTube channel. If you're not subscribed to my YouTube channel, please do click on the subscription button and subscribe so that you don't miss any active videos that I post, and we may go hand in hand in learning and help each other to excel in our examinations. So let us start the program for today. Index notation in the subtopic talking of indices. In other words, we are saying index notation is a way of expressing repetitive multiplication. Now, repetitive multiplication, they are simply meaning the product of, for example, the product of 3 times 3 times 3 times 3. Now, this is what it means to be repetitive. It simply means that it is repeating itself. Now, 3 times 3 times 3 times 3, this is equal to 81. If you punch your calculator, you are going to find 81, which can be expressed as 3 to the power 4. 3 to the power 4. Now, when you write 3 to the power 4, it is another way we can simply come to understand it and say, when we write 3 to the power 4, now 3 in this case is called the base. 3 is called the base, while 4 is called the power or index, or sometimes you can call it exponent. Now, having understood what this part is all about, therefore now we can come and look at the principles or the laws that govern manipulation, evaluation of indices. If you understand these rules that we're about to do, then we can say indices will not have any problem in your examination paper. So now let's look at these index, the laws. Now, the first law, it is zero index. This is the first law that you should at least know. Even a grade 1 pupil would know what this law is, should know what this law is. We are simply saying any number other than 0 raised to power 0 is equal to 1. Any number rather than 0, okay? So meaning that the number should not be equal to 0, or the number should not be 0, but the number should be greater than 0. Okay, that number when raised to power 0 is equal to 1. That's what this zero index law is telling us. They have given us this example here. X to power 0 is equal to 1. Any number, be it 100 to power 0, the answer should be 1. Be it 275 to power 0, the answer should be 1. So any number raised to power 0, the answer will should be 0. It should be 1, I mean. Now, note the number 1 can be expressed in any base raised to power 0. So it can be any base like 100 or 275. As long as it's raised to power 0, I will still get my 1 as a correct answer. Let's hope there is no any problem on this one. Let's progress. Unit power. Now, unit power, what does unit power mean? Unit power simply is talking of any number raised to power 1 is that number itself. Any number raised to power 1 is that number itself. For example, x to power 1, the answer should be x. 100 to power 1, the answer should be 100. 578 to power 1, the answer should be 578. So this is about the unit power law. So don't forget this because it will be helpful in your examination questions, as we shall look at some of the samples from different years of the ECZ past paper examination questions. Now, let's look at the third law, which is negative power. Negative power. Now, this one, pay particular attention because it is one of the laws that confuses a lot of people. Now, we are saying that given any two real numbers, x and n, these are real numbers, x raised to power negative 1, it is the same way as 1 over x to power n. Here, this law is simply telling us that if a number is raised to power negative, You cannot simplify this the way it is, but you now need to transform or change it into this manner whereby you get rid of this negative. Therefore, now you can easily solve the question without any difficulties. Let's look at the example. Example number one. Example number one. So the example is simply saying evaluate 3 to power negative 2. Evaluate 3 to power negative 2. So how do we evaluate this one? We are simply saying 3 to power negative 2. How we evaluate this one is to remember the row. So let us remember, we are remembering what? The law, which negative the law, okay, which is the negative law, which is the negative power, okay, which is the negative power. What are they simply saying here? We know the law, by the law, it states that if you're given a number like this, you need to change the negative part into a positive, then we can get our answer correct. So the law is x raised to power negative 1 is simply 1 over x to power, to power n. This is the law that we have learned. So we need to change this question into this format. So how are we going to do it? We are saying 1 over 3 to power 2. Therefore, you can simplify it further by saying 1 over, what is 3 to power 2? 3 raised to power 2, they are simply saying 3 multiplied by 3, which will be 1 over 9. So this will be our final answer. Using the negative power law of indices, we get our answer as simple as straightforward. Let's hope there won't be any problems on this part. Now, having understood what the index law is all about, now, and also the unit law, what is all about, and also having understood the negative power law, what is all about, let us now look at the multiplication law. What does the multiplication law has to say? The multiplication law is saying if we multiply numbers of the same base, if we multiply numbers of the same base, we maintain the base and add the powers. Meaning that if the bases are the same, we maintain the base and add the powers. For instance, if A, B, M, and N are a member of real numbers, and A to power M and A to power N, then we are saying that A to power M times A to power N, this is same as A, maintain the base and add the powers, M plus N. This is the multiplication law. Now, what kind of an example can be given here? The example that can be given here under the multiplication, let's look at the multiplication law. The multiplication law. Okay, the multiplication law, we are we know that if A to power M times A to power N, these are the bases. The bases are the same. What we need to do is simply maintain the base and add the powers, meaning M plus N will be added. Now, given an example, we are simplifying y to power 2 times y to power 4. How do we simplify this? Solution for this one. So the only part we are going to do here is to say y to power 2 times y to power 4. The bases are the same. You look at the bases. This base and this are the same. So what you do is simply maintain the base, which is y, and then 2 plus 4. You add them, which you are going to get your answers y to power 6. And this will be your final answer. As simple as that. So now let's look at another example. What if let this be my A and my B, let it be simplified 2 to power 5 times 2 to power 3. So my B therefore is going to be 2 to power 5 times 2 to power 3, which is, the bases are the same, so it will be 2 to power 5 plus 3. and therefore my final answer will be 2 to power 5, 8. 2 to power 8. This will be the final answer. So you leave your answer in that format, or you can simplify it further, but this is the best way you do it like this. It's a matter of understanding the law. Done with this law. Now, having understood the multiplication law, let us look at the fifth law, which is the division law. What does the division law has to say? If we divide numbers of the same base, we subtract the powers. So it's the opposite of the multiplication. When we are multiplying the bases, as long as the bases are the same and we are multiplying, the powers are supposed to be added. Now on division, when you are dividing, the bases are the same. What we do with the powers is simply subtract. The example given here it is, when you are given the example of division, here we are talking of division, okay? Division law, okay, of indices. We are told that if the bases are the same and we are dividing, all we have to do is to maintain the base and subtract the powers. Simple. So now we are given the example saying, here is an example. Simplify. We are simplifying y to power 6 divided by y to power 4. This is our A. And our B, it is 2 to power 5 divided by 2 to power 3. So now when you look at these ones, the bases are the same. So how do we do it using this law? We are simply saying maintain the base and subtract the powers. So meaning the final answer will be y to power 2. And this one here, it will be maintain the base and subtract the powers, which will be 2 to power 2. So we see this is how we work out this law, division law of indices. Memorize this and you'll not have any problem in your exam. Let us proceed and look at another interesting law, which of course is very important for you to note as you are heading to your examination room. Now, fraction power, positive power. So the fraction power law has two ways, the negative power and also the positive power. Now let us look at the positive power. So the fraction, okay, power. Now here we are simply talking of the positive. We are concentrating more on the positive power there. So what do we do on this part? So the positive power is our main interest. So we are told that for x, y, m, n, as long as the member of real numbers, then y to power m over n as a fraction, we can simply evaluate this as y to power m, raise it, multiply it to 1 over n, which when you multiply this, we are getting this part. And we can simplify it further. Or we can simply say, put this n into this square root, and y, all these things should be raised to power m. What does this mean? This simply means that what number can we multiply n times that we are going to get y, and that number we should multiply it with m, and that will be our final answer. For example, we are given evaluate 8 to power 2 over 3. So how we work out this one, there are two methods I'll show you. So the first one, by using the law, we are simply saying that what we should do on this one is 8. You see 8, we can raise this to 1 over 3 multiply by 2. Or in other way around, we can do this. Or we can simply say, we introduce the square root. This 3 which is here goes on this V shape. And then we write 8, all this should be multiplied by 2. So what I was saying is, what number can we multiply 3 times and we are going to get 8? That is 2. So when we say 2 multiplied by 3 times, it simply means that 2 will be raised to power 2. And our final answer will just be 4. So 2, when we say 8 to power 2 over 3, how we work out this one is straightforward as this. We get our answer to be 4. Or you can want to use a different method. What other method can you say? We can say 8 raised to power 2 over 3, the best way to simplify is change the base. We are going to say 2 to power 3, multiply all this by 2 over 3. So you see, this 3 and this 3 divide each other, cancel. We are saying that now 2 is raised to power 2, and 2 to power 2 is simply 4. So this method or this method, whichever you use, you are going to get the answer correct. Hope that was helpful. Now let us look at the last but not the least law of indices, which is of course important, and this is of the fraction power of negative powers. So we looked at the positive power. Now let us look of the fraction power, which is the same law but negative. Our main interest is negative now. So how do we do this kind of equation? We are given a question as 8 to power negative 2 over 3. So you notice that this question and this question, the answers will not be the same because here there's a negative. The answers will be different. So the first thing is, how do you get rid of the negative? We need to remember we looked at the negative law of indices. So we are saying that the first step what we should do is get rid of the negative. So for me to get rid of the negative, in other ways, we are simply saying I should work it in this manner, change the base. So this kind of work, it will be 2 to power 3 multiplied by negative 2 over 3, which of course will be 3 multiplied by negative 2 will be 2 to power negative 6 over 3, which will give me 3 into 6, which is 2 to power negative 2. Okay, 3 into 6, which is 2 to power negative 2. Because of this negative here, I need to transform this. How do I change this? It will be 1 over 2 to power 2. And my final answer, therefore, it will be 1 over 4. As you can see, there was a negative, but this had no negative, and the answer was 4. But because of the negative, we have 1 over 4 as our final answer. So this is how we work negative powers when you are dealing with the negative fractions of indices. So once you do this, then you not have a problem in your examination. Now let us look at the last but not the least law of indices. Okay, this law also is very important. When we are given a question of this caliber, we need to know how to work it best. Okay, so we are saying that if A, M, N, this is a law. When you're given this kind of a question, how do we do with this work? We are simply saying that we multiply the power of A multiplied by the outside power also. So this will simply be A to power M times N. As simple as that. And we get our final answer to be A to power N multiplied by M. Just like that. So the next example that we can do on this question is 3 to power 2 multiplied by 4. How do we work out this one? The way we work out to this one, we are simply saying 2 multiplied by 4, it is going to be 2 multiplied by that, it is 2 multiplied by 4, which is 3 to power 8. And this is how we work out this simple question. Hope this was very helpful. Let us meet in the next practical questions that we are going to do in the next video for our examinations. So make sure that you don't miss the next video. If you are not subscribed to this YouTube channel, subscribe so that the next questions that are going to come are going to be easily done and understood, because we have understood this concept of indices. Thank you. God bless.